Hello, my name is Daniel Jacoven, and welcome to my data presentation based off of our forum assignment on week 2. So yes, I'm going to be talking about two general tools and the data I'm going to be using with them. One tool I'm using is Microsoft Excel. This is the online version, but I will be using the full-on version. Instead, the online version is just too slimmed down, and I'm also be using PowerPoint. And I guess I'll just pull up PowerPoint online to very quickly exemplify that. So yeah, that'll open up. And when I go to edit, wait, no. When I go to edit, all the buttons will show up and everything, and it's lots of buttons. So yes. So going back to Excel, what we have here is the something that tabulates the average age of automobiles and trucks, just three categories that pertain to automobiles and trucks over a 21 span going from the year 1995 to 2016. Now, if I want to talk about this in summary, overall, I mean, the year changed drastically. It's a 21-year span, but the average age only changes 3.3 years. That suggests a lot of things, which I'll cover when I talk about confounding variables very soon. So to summarize very quickly, pertaining to types of variables and to harken back to week 2, we have categorical variables. These are the passenger cars, light trucks, and all light vehicles. Your passenger cars are cars that are used for commute. These are cars that are optimized for commuting, like sedans, something of that class. Not talking about a sport utility vehicle or a Humvee or something like that. This is a passenger car. This is like your Corollas and Camrys and your Maximos and stuff like that. Then you have your light trucks, which is probably includes pickup trucks too, because they're kind of meant for the same purpose as the other light trucks. And you have all light vehicles, and that's things like jet skis, motorbikes. It extends to all automobiles. Doesn't necessarily have to pertain to the four-wheeled kind. It could just be any motorized vehicle, really. I guess speedboats go in there too. So yes, so that's our categorical variables. They're categorical because they have scalar quantities that measure them and stuff, and they're objects. It's really something for purposes. So yeah. You also have the continuous quantitative variables. That's the scalars you see right here. That's the ages of the cars. That goes up with the years. Now again, we can talk about possible lurking variables. Before I try to explain why the age of the car budgets so little versus versus just time itself over 21 years. And to re-enumerate that, I think it's because people are buying new cars as much as they're keeping their old ones. I mean, they're starting off pretty old. As you can see, I mean, cars are really old. Like, for a 2060 car, you have an 11-year-old car. So that, like 11.6, sorry. So that means your car is like what? More from 2005? If you recall, 2005 car is pretty old. And the years aren't budging so much. So a lot of people are still buying new cars, even though holding on to their old ones. I mean, I know I had an old car. And so when I was in 2014, when I was 22, just 3 years ago, I had a car from 2005. Thing had 75,000 miles on it. It had seen its days, So yeah, there you go. I guess so. Of course, for that reason, of course, buying used cars might factor in there too. That might be another lurking variable. So yes, another thing is association and causation. So yeah, obviously the year of the car is just being tacked on with the age of the car. They're not really going up in such a one-to-one fashion where the year of the car is actually taking full control over the age of the car. No, there's something that links in between. So that's a pure association. There's a confounding variable. So again, it's a pure association. As far as causation and stuff, the year of the car is only going to budge so much. Time is only going to influence so much. We're people. We have a horizon of association. We can step aside from subconscious stimulus and all this stuff, and we can consciously think about things on a conscious level, and on a reasoning level. So think it's going to cause another confounding variable that And so so as far as causation goes, these years only have the smallest influence. Um, yeah, it, it it's a very small fractional strength of influence. Like if you think about it in continuum. Um, so yeah. If I had to say more about summarizing the data, I guess I could apply something we we just recently learned about, which is the five number summary. By taking the five number summary, which is the minimum value of these ages, the lower quartile, which is 25th percentile, the median, the upper percentile is 75th, or the upper um, or the upper quartile, and the maximum of the data. This gives us, in the long run, a criteria for establishing outliers. So, you know, we so when we look at the curve of progression, obviously it's not going to follow a straight line. It kind of, goes back to the problem of smooth curves. So this line of progression, sorry, is going to progress, and this 5 point data summary is going to give us the key to understanding what's going to be an outlier and what's not, so we can obtain a random fluctuation that mimics the real progression of the average age. Because yeah, we could obtain a line of best fit. Excel does that in moments, and I'll talk a little bit about what Excel does. Excel does that in moments, but but it's just not as accurate. It's not as accurate. Yeah, it's important to understand the limits of these natural fluctuations. So yeah, based on that five number summary, we can use the different equations for the upper and lower bound of an outlier. Um, Q sub 1 minus 1.5 times IQR for the lower value, and then Q sub 3 plus 1.5 times IQR. So yeah, now about Excel. So why am I choosing Excel? Well, I mean, this data is pretty cluttered. It's not really intuitive. It's just a bunch of numbers. Excel allows me to do line graphs, pie graphs, well, all sorts of 3D graphics and everything. I could do custom images, whatever I want. And which is great, because if you're a person that already has a good idea for what they want to put down, they can put it down, and then their presentation is that much better. What Excel basically does is it's just something. It's kind of like a really advanced graphing calculator, but it does programming routines also, so you can do conditional statements and loops and all sorts of stuff. It's pretty full on. You know, I can refer to any two cells and use them as variables in an equation and stuff, and come out with the result and represent it as a graph. And yeah, it's basically what it is. It's like part compiler, part graphing calculator. And you have to know the two skills that entails, which is a programming and mathematics, to be able to use it. Obviously, you have to be able to read the buttons too, but that's something that's with every computer program. So yes, my second tool, another well-established, very versatile tool, which is PowerPoint. PowerPoint is great for making things even more visually appealing. I could take the highly visual appealing result I get from Excel, um, and put it into a PowerPoint, and I can do custom backgrounds like I did right here. This was done in Photoshop, and I can just clean out the clutter, all the black lines and everything, and I could add colors and really focus on the essential data for something that really grips attention. So that's why I'm using it. And what kind of result might I get from that? I mean, I could arrive at something like this and stuff from something pretty bare bones like this. This is how Excel generates an image of a table. It's fairly clean, but it's still a bunch of numbers. Over here, again, still a bunch of numbers. I could take it up so much higher and have a visual graph with like textured 3D objects, and in PowerPoint I can add music and add custom videos to slides, and probably animate graphs too. I mean, I have a program for doing animation right here that's called Blender. Oh, and conveniently the Blender icon pops up. That's cool. The little text pops up. So yes, yeah, I have two very big tools for doing this. There's lots of buttons and lots of things that can be done here, for a really professional looking job. Something that goes way beyond something like this, even though this is a formatted table and it's nice and spaced out. to me, that's really just 2 or 3 tricks thrown in there. I could throw in 30 or 40 with all the buttons I have here. Yeah, sky's the limit. So yes, I hope you enjoyed the presentation, and thank you for taking the time out to listen to my presentation, and have a great time.